Hi, Algebra 1. I'm just making a quick video that will help you to get your DeltaMath done this week in case you're struggling or if you missed class. I'm just going to do 2 problems from each section to remind you of how to use exponent rules to simplify these problems. So I'll start with doing 2 problems from the basic exponent rules section. You need to do 3 in this section. Okay. So this is telling us to simplify to a single power of 3. It's really nice because the DeltaMath already gives you that base of 3 written, and you just have to replace whatever number you think the exponent should be here. Now, I see that the problem I have is 3 times 3 to the third power. Since I have 2 common bases, my common base here is 3 because they both have the base of 3. Since I have the common base of 3 and they're being multiplied, I'm going to use the product rule. Now, I don't have it up on my screen, but if you go over our notes from the lesson or our slides from the lesson, / if you remember from class, the product rule means that when we are multiplying numbers with the same base, we get to add their exponents to give us the new exponent. Now you might be wondering, what is the exponent on this 3? I don't see an exponent here. Well, on this 3, since we don't see an exponent, it's actually an exponent of 1. Okay, the way I remember that is I see 1, 3 here. And so if I see 1, 3, I know it has an invisible exponent of 1. So the 3 on the left has an exponent of 1, and the 3 on the right has an exponent of 3. So I need to add together those exponents, 1 plus 3, and that gives me the new exponent of 4. So my answer is 3 to the 4th power. I'm going to click submit. I'm correct. Great. And as you can see, this is kind of how we learned it the long way in class, and then we started using the shortcuts. Up here, it's the expanding idea of, okay, we have a single 3, and then we have 3 3s being multiplied from the 3 to the third. If you count them all up together, it's 4 3s being multiplied, so you get 3 to the 4th. And method 2 is basically just the shortcut I just showed you, which is really what you need to know. This is a great way of learning the method 1 and understanding where the rule comes from, and then we can just use this shortcut from now on, okay? So my next problem is 2 to the 4th raised to the 5th power. This is where we use the power to a power rule. We have 2 exponents here. Now, if you remember from class, the power to a power rule tells us if we have an exponent raised to another exponent, we get to multiply the exponents together. So I have the exponent of 4 inside the parentheses and the exponent of 5 outside the parentheses. So I get to multiply 4 times 5 to give me my new exponent of 20. So my answer is 2 to the power of 20. I'm going to submit that. Okay. And again, you can see, look how many 2's there are. Okay, when I have 2 to the 4th to the 5th power, that means I'm multiplying 2 to the 4th 5 times. And then each of those 2 to the 4ths have 4 2's being multiplied. So I end up with 5 groups of 4 2's being multiplied, which is 20 2's. Now, of course, I would not expect you to do that to figure this out. That's why we use this shortcut method, which is when we have power to a power, we just multiply the powers to give us our new power, okay? I'm going to do one more. If I can find one that is going to be quotient rule. Okay, yeah. I'll just do one more so that you can see the third rule, which is the third rule we learned on the first day of class this week. So this says simplify to a single power of 3. So just like how in the product rule we could multiply, when we were multiplying with the same base, we could add the exponents. Now the quotient rule says when we're dividing with the same base, we get to subtract the exponents. So we're dividing 3 to the 5th divided by 3 to the 3rd. They have the common base of 3, which means we get to subtract 5 minus 3 to give us the new exponent of 2. Now, something really important to remember is you should always subtract the top exponent by the bottom exponent. So 5 minus 3, always the top minus the bottom exponent. So my answer is 3 to the 2nd power. All right. And as you can see, this is how we kind of learned it at first in class. We expanded all of the 3's or 5 3's on top, 3 3's on the bottom, and then we cancel it out, 3 on the top and 3 on the bottom, and we were left with 2 3's being multiplied, so 3 squared. But we like to use the shortcut now where we just subtract the powers, all right? And now that we've done 3 of those, I'll do like 1 or 2 of these. The exponent rules with the variable only. It's the same exact idea, but you do have to type the base yourself this time in the exponent. And you're going to have variables here. So only letters, no numbers. So this one is p to the 5th to the 4th power. So that's power to a power rule. My base is p, so I'm going to type a p. And then to get my new exponent, power to a power says I get to multiply the exponents 5 times 4, which gives me 20. Remember to use shift 6. That's how I get my exponent. Shift 6 on my computer lets me type up in the exponent 20. If you don't do that, and you type a 20 like this, it will be marked wrong. Shift 6 and you get the 20. Click submit. That is correct. I can do one more. Same thing, m to the 6th. Let's see if I can actually get a different problem. Here, this one is y times y to the 5th. Okay, just like with the 3 that I showed you earlier, I see the y by itself here. That means it has an exponent of 1 that you cannot see. So imagine an invisible exponent of 1 on this y, and it's being multiplied with y to the 5th. So that means I get to add the exponents. So of course my base is going to be y. And then I add the exponents, the invisible 1 plus 5 gives me the new exponent of 6. So y to the 6th would be my answer. I don't think I need to do another one. That should be good for you guys. Now I will do a couple from the negative and 0 exponent section. This is multiple choice. And so with negative exponents, what we learned is that whenever we have a negative exponent, we want to take that exponent, make it positive, and move the whole thing into the denominator. So what I'm going to do here is, before I even think about the negative exponent, I want to figure out what rule I can apply here. I have 3 to the negative 4th times 3 to the 6th. So since I see multiplication happening, I know I can use my product rule first to combine these. And then when I need to use my negative exponent rule, I'll get to that. So the first thing I'm thinking is I can add my exponents because it's the product rule. So negative 4 plus 6. Now, some of you sometimes struggle with adding negative numbers and positive numbers together. Do it in a calculator to make sure you're right. But negative 4 plus 6 would give me a positive 2. So that means I'm going to get 3 to the 2nd power. So I actually didn't really even need to apply my negative exponent rule yet because these ended up adding to give me a positive exponent. So my 3 stays on top with its exponent, okay? When you have a negative exponent, if you end with a negative exponent, that's when you're going to have to put it into the denominator. It might look something like this. But in this case, negative 4 plus 6 gave us a positive 2 exponent. So we don't need to make a fraction. It's just 3 squared. That was a good example to show you that it's not just because you see a negative exponent in the original problem doesn't mean it's going to end up a fraction. You got to apply your other rules first and then see if you still have a negative exponent. So 3 squared. Yes, let's try another one. This one, 5 to the negative 6th to the negative 3rd power. Okay, before I even try and use my negative exponent rule, I want to make sure that I've used every other rule I know. Well, this is power to a power, so I need to use my power to a power rule. Negative 6 times negative 3 is going to give me positive 18. Again, make sure you use a calculator if you struggle with that. Negative 6 times negative 3 gives me positive 18. Look at that. My negatives are gone now. It's just 5 to the positive 18 power. I don't even need to worry about that negative exponent rule again for this one because the 2 negatives multiplied to a positive exponent. Let's try another. Okay, this one's good because we're going to end up with a negative here. So I have 3 to the negative 4th divided by 3. Now remember, 3 by itself has an invisible exponent of 1. Okay, so, and I see I have a quotient here. I have something being divided. So I'm going to start with using my quotient rule. That means I'm going to subtract the top exponent minus the bottom exponent, which is 1. Always top minus bottom. So negative 4 minus 1, that would give me 3 to the negative 5th. Now, of course, as you can see, 3 to the negative 5th is not even an option here. Okay, that's because when I never want to leave my final expression with a negative exponent. Okay, I want to move 3 to the negative 5th to the denominator and make its exponent positive. So if I have 3 to the negative 5th, that means I'm going to put it underneath a 1 on top, and I'm going to make that exponent positive. So it's 1 over 3 to the 5th. So instead of 3 to the negative 5th, I use my negative exponent rule to get 1 over 3 to the positive 5th. I'll see if I can do one more that kind of uses that negative exponent rule just to show you. Let's see if I can just do one more. Okay, this is another good one. So 2 to the negative 5th divided by 2 to the negative 1st. So I'm going to do negative 5 minus negative 1 because it's my quotient rule. Top minus bottom, negative 5 minus negative 1. Again, use a calculator if you're not sure, but negative 5 minus negative 1. Minus a negative means I'm actually adding 1. So negative 5 plus 1, that would give me negative 4. So 2 to the negative 4th. And in this example, they actually just left it as 2 to the negative 4th. That is an equivalent expression to what we have here. Another equivalent expression would be if I were to take 2 to the negative 4th, make the exponent positive, put it in the denominator below a 1 over 2 to the 4th. Those are all equal, you know, so sometimes the option it gives you is a negative exponent. Sometimes it converts it to a fraction. All of them are equal, and that's, as long as you know that, that's what matters. So this is the correct answer, but if you saw the option 1 over 2 to the 4th, that would also be correct. That would also be an equivalent expression, okay? So that should help you with your DeltaMath. We didn't have any examples with 0 exponents. Oh, here's one. I'll just do it real quick. 2 to the negative 6th times 2 to the positive 6. So they have the same base of 2 and they're being multiplied. So I get to use the product rule, which means I add my exponents, negative 6 plus 6. Negative 6 plus 6 cancel out together to leave us with 0. Now that doesn't mean the answer is 0. That means when I add negative 6 plus 6, I get 2 to the power of 0. 2 to the power of 0, well, anything to the power of 0 is 1. That's our 0 exponent rule. Anything to the power of 0 is equal to 1. So since I have 2 to the power of 0, and that's not an option, 2 to the power of 0, well, that's also equal to 1. So my answer would be 1. All right, I think that's covered everything that you'll run into. And good luck. You're good to go.